Couldn't go a day without caffeine, I don't think. Haven't tried. It's nice, bit of fresh air. I have lots of concerns about the sustainability of most things we do on Earth, like where it's sort of talking about consumption and production of goods, where we're like contributing to lots of emissions and climate change, and at the same time we've got all this waste building up that we don't know what to do with. I want and we need to do something about it. In early high school, a lot of the teachers sort of didn't believe that I would get a good like high school score or ATAR score, because I said, I'm not trying now, I'll just try in year 11 and 12 because that's what matters. And then I got an alright score, but I wasn't like the brainiac. I was just sort of your average Joe that was a bit interested in maths. So this is my desk from the work that I did in my PhD. I'll have to try and remember the title of it. I think it was Circular Textiles, Redesigning Textile Fibres for a Circular Economy. Before my PhD, I had no idea about textiles and their impact. There's different stats out there, but people nowadays are saying it's the textile industry is the second biggest polluter in the world. This experiment today, it's a bit of a two for the price of one. First, I'm going to use a machine learning model to predict the cellulose solubility or cotton solubility in our solvents, working with some people from A Squared, I Squared, I think it's the Applied Artificial Intelligence Institute here at Deakin. So I'll predict the solubility of high DP cotton. Then this should predict, so it thinks we're going to get 8.05 weight% of cellulose in there. And then we're going to go test it experimentally in the lab. Myself and Nilipul. So Nilipul is a PhD student.
We don't know how it works because this is quite different material and new combination. So yeah, we'll see.
His project is about separating elastane or spandex from cotton, which is super important because just a little bit of spandex can make it really hard to recycle waste cotton textiles. So we're going to use waste cotton as the cellulose source, and we're going to use ionic liquids as the solvents, and we'll basically just heat them up and stir them for about 4 hours. Oh, it doesn't come off easy, that's for sure. Come in, Nilipul. These experiments today will show either high DP cellulose dissolves at this concentration or it doesn't. If it doesn't, we still don't know if it's the spandex or the cotton, but if it does, it's because of the spandex in the solution. So then you can go back to the drawing board and figure out how to optimise that separation, which then we can test later. What we've got here is 2, 4, 6, 8, 10. So they're the concentrations of cellulose that we're going to put in there with some Kim wipes from Kim's desk. Do you want to go and mix in that? Oh, I'm hanging for a coffee. Usually I have 2 instant coffees before I start work. I hope this works. For me, it's a win-win because I'll have something to put into the machine learning model. For Nilipul, if it dissolves 4 weight% or above, then we can confirm that it's the spandex causing the problem with his dissolution. If it dissolves under that, I suppose it's a half win because whatever concentration it dissolves at, you can test your separated cotton at that concentration and that'll give us the conclusion we need. Awesome. And then I think we can put it on the heat. So it's 11:30. There we go. So that's mixing now.
To get the stretchability and comfortability, we add spandex into fabric, but there's no specific sustainable method in the industry to scaling up the recycling method. So my target is to separate the component, mainly focusing on mechanical separation and using environmental friendly chemicals, and at the moment we are observing promising results as well.
Let's get a coffee. I think we've got to go. Or go regular oat cappuccino in that one, please. Bit of a band-aid from chipping my knuckle, building some outdoor stairs from our deck. It's worth it in the end. I'm a lot safer at work than I am at home, I think. There's too many collars going on here. We've got our solutions. This is quite dissolved. That's basically liquid cotton, ready, almost ready for making fibres with. This is 2% of the cotton, this is 4%, and if we tip them, one flows and one doesn't. Alright, so now we're going to go get some lunch. Got some microplastics into my pasta for microwaving it in the plastic container, but use all your leftovers. Alright, I think we've got lunch. It's not always the case if it's visually dissolved to the eye, then it's microscopically dissolved as well. So we have to we can see and say, looks dissolved, and then we confirm dissolution by looking at it in the microscope. Being able to read about something or do some calculations and then say, all right, this is what's going to happen, and then you go and do it in real life and it works, you're like, science. It's just really cool seeing theories and ideas and equations come to life through experiments. I'll leave that there. This is good to go. Super important. One hand, one glove. You carry your sample with your gloved hand, so you don't use your glove on the door handle, because we don't want to contaminate the door handles. We'll see if we can find some other regions of undissolved stuff in here. Here we go. This is our slide with some dust particles, and this moving is our cellulose solution on the slide. So this is, from what I can see so far, and I'll just scan all the way up, I think it's fully dissolved. The 2% solution was fully dissolved. Oh, right. So next step for you would be to test your cotton sample at 2% in the same solvent. It gives us a good result, but not the best result. It would have been the best if it dissolved the 4% My model won't be happy though. It's not accurate. If you're filming a day in the life of a scientist and everything worked perfectly, it wouldn't be a typical day in the life of a scientist. It would be a 1 in 100 day in the life of a scientist, because that's what we're doing most of the time. We're checking things to make sure they don't work, and then we don't have to do them again. But we're not necessarily making the big breakthroughs every day. Take a photo from the top. So I'll just quickly wash my hands. Even though today was a bit routine in the work that we did, we weren't expecting any big results or trying to do anything too ambitious. I try and look at it in the way that you can't have a bad experiment, because you always learn something that doesn't work or what not to do next time. So I think it's a good way to not be constantly disappointed when you're in science. I'll look at the Cape Sorel buoy data and see if there's a swell showing up, and hopefully go for a freezing cold surf tomorrow morning.